So we want to find the intervals of concavity, and we have x times x minus 4 cubed. What is the first step? Find the derivative, and keep in mind, oftentimes the first derivative would give you information about, where things are concave up and concave down. But if you want to find the exact point of inflection, you need the second derivative test. So f of x is x times x minus 4 cubed. Yes? And we all know how to find the derivative. So find the first derivative of this, but do not FOIL and make it way too complicated. Just take the derivative, but do not make it complicated. Give you about 2 minutes. So we have u and v. So that is the part that is going to require chain rule. So u is x and v is x minus 4 cubed. U prime is just 1. V prime, if I use chain rule, this would be 3 times x minus 4 squared multiplied by the derivative of whatever term that we have inside, which is 1. So f prime of x is uv prime plus v u prime. U is x, v prime is 3 times x minus 4 squared. V is x minus 4 cubed. U prime is just 1. I ought to not to simplify, not to make this complicated in the sense, don't FOIL this, expand that, and make life harder yourself. Why? We are going to set this equal to 0 and solve for x, so we can get rid of terms easily if we don't overcomplicate things. So we have 3x multiplied by x minus 4 squared plus x minus 4 cubed. What do we have in common between the two terms?
X minus 4 squared.
X minus 4 squared. If I pull that term out, I would have 3x. What do I leave behind here?
X minus 4.
X minus 4. Three x plus x is 4x, and minus 4. What do we have in common among those two terms?
2 or 4.
4. Yes. What is the next step?
Set them each equal 0.
Set the derivative equal to 0 and solve for x. How do we solve for this? You should know the answer just by looking at it. What would make that expression 0?
4 and 1.
If I plug in 4, it's going to become 0. If I plug in 1, it would become 0. So, if you don't see it that way, divide by 4 on both sides. We have x minus 4 squared times x minus 1 equals 0. Each of them is a factor. So, set the first factor equal to 0. Take the square root, it would become x minus 4. Move the 4 to the other side, we get 4. Yes? And do the same thing with the second factor. X minus 1 equals 0. Move the 1 to the other side, we have x is equal to 1. What are these values called? Critical values. Increasing and decreasing intervals, so we know the critical values. X is equal to 4 is 1, x is equal to 1 is the other. So I could simply choose 4 and 1 on the x-axis. First critical value, second critical value. What do we do next?
Pick points on either side.
Pick easy points on each side to see the behavior. So, what easy number can we pick less than 1?
0.
0. Where should we plug that value?
First derivative.
In the first derivative. So, f prime of 0 would be 4 times 0 minus 4 squared times 0 minus 1. Now, I've seen students sit and evaluate the exact value of this expression. In a problem like this, it is not necessary. All we need is the sign, because all we care about is the sign. So, I don't need the exact value. So, is 4 a positive number?
Yep.
Yes. Have negative 4 by square root, would I get a positive number? Yes. 0 minus 1, that's a negative number. Positive, positive, negative, we get negative. Which would mean that the function is decreasing. Right? Connor, you have that look. Now, if you want to evaluate the number, the answer here is negative 64. But what I'm saying is you don't have to evaluate each value, just recognize their signs, and if it's a negative sign, it's decreasing.
So all it takes is one negative sign?
Yeah. You know, positive, positive, negative. Between 1 and 4, I'm going to plug in 2. Four is a positive number. 2 minus 4 is negative 2, but negative 2 squared will result in a positive number. Agreed. 2 minus 1 is positive as well, right? So positive times positive times positive is positive. If you are adamant about plugging in the values and getting the exact value, go for it. The reason why I I'm telling you, well, the sign is all that matters, and you don't have to evaluate the exact values, because what if you had a fraction or a large number of sorts? You'd be wasting a lot of time trying to find that exact value, when all that matters is the sign. And pick an easy number greater than 4. 5. So 4 times 5 minus 4 squared. And 5 minus 1. Four is positive. 5 minus 4 is 1. 1 squared is positive. 5 minus 1 is 4. Positive. Positive times positive is a positive number. Yes? Decreasing, increasing, increasing. Good? Okay, can I erase this side? So it is decreasing from minus infinity all the way up to one. How would you write the next part? It keeps going up and up, right? After 1. So how should we write it?
1 to infinity.
Jaden, right?
Yeah.
Jaden says 1 to infinity. I'm going to disagree with him. He was close.
Would it be 1 to 4 and then 4 to infinity?
1 to 4 and 4 to infinity. Moses, care to enlighten us?
So once we hit 1, it starts moving up towards infinity, but then we have 4 in between that. So it's like a stopping point. I don't know, I can't really explain it, but once we hit the 4, we keep going into infinity. So
Right. A critical value is a value where the derivative is 0, right? If the derivative is 0, the function is neither increasing nor decreasing at that instant. In other words, it is constant. So if I have to hypothetically draw a curve, this is going to somewhat look like something like that. It will probably touch and turn right there. Oh, it's increasing. So it'll be flat at that point. And because at 4, it's neither increasing nor decreasing. I'll wait until the second derivative so that I get a better picture. Good with that part? So we know f prime of x is 4 times x minus 4 squared times x minus 1. I'll give you about 2 minutes. Go ahead and find the second derivative. I could put this 4 there or there, doesn't matter. What I'm going, because 4 is a constant. So I'll keep that full as is and take the derivative of whatever that we have inside. So u, v prime plus v, u prime. U now is x minus 4 squared. V is x minus 1. What is u prime? U prime is 2x minus 4 multiplied by the derivative of whatever that is inside, simply 1. Chain. V prime is 1, derivative of x is 1, and derivative of minus 1 is simply 0. So f double prime of x would be 4 multiplied by u, x minus 4 squared. V prime is 1. V is x minus 1. U prime is 2 times x minus 4. Yes? What do we have in common between that term and that term? What factor is in common?
X minus 4.
X minus 4. If x minus 4 comes out of x minus 4 squared, what would we leave behind?
X minus 4.
X minus 4. I have x minus 1 times 2 times x minus 4, and that term is being pulled out. What do we leave behind? Is Moses is the only person who is alive? What do we pull out? X minus 4. What do we leave behind?
2x minus 2. 2x minus 2.
2 times x minus 1. So we have 4 times x minus 4, x minus 4 plus 2x minus 2. 2x plus x is 3x. Negative 4, negative 2 is negative 6. What do we have in common between those two terms?
3.
3. So I'm going to pull that 3 out. And what is 4 times 3?
12.
12. And that is the second derivative. Do you see why it is beneficial to keep things in factors? Had I foiled everything and got a lengthy expression, which would in this case be a cubic polynomial, fourth degree polynomial, there is no way that you could get an answer, in a speedy manner. What do I mean by that? If I set that equal to 0, I'm going to erase this side, can I? Is it? I think it's 5. If I set the second derivative equal to 0 and I solve for x, what would I get?
The concavity.
The solution that I'm going to get.
The point of inflection.
The point of inflection. So divide by 12 on both sides. So set each factor equal to 0. So those are my points of inflection. Because the second derivative becomes 0, and we got the point of inflection. What happens at the point of inflection? This is from last time. If you saw the video, you will know.
The concavity changes.
The concavity changes. It moves from concave up to concave down, or concave down to concave up. That's a bad line. What were the critical values?
4 and 2.
Come again?
4 and 2.
Critical value. From the last part.
Oh.
That's the derivative test.
1, 4.
1 and 4. Now there's 2 and 4. 2 is a point of inflection, so is 4. Right? Now, when you pick the point, you've got to be careful as to what you're testing for. Don't get confused by this 1. The 1 is the critical value, not the point of inflection. In this problem, we're trying to find the point of inflection. Good. So, we have to pick a number less than 2. Easy number less than 2.
0.
0. We should take that 0 and plug it in the second derivative. So if you want to evaluate, you can evaluate it, that is 96, or simply look at the sign. 12 is a positive number, 0 minus 4 is negative, negative number, 0 minus 2 is negative, negative number. So positive times negative will give you a positive number. If the second derivative is positive for a test value, it has to be concave up. It's not drawn properly. I should probably draw it right. I know that 1 is a critical value, right? So the point where it turns should be at 1, agreed? So perhaps I'll try really hard. Okay. 2 is an inflection point. Yes? So between those two, what do we expect to happen?
It would be equal to 0.
No, between these 2 points. the concavity. 2 is a point of inflection. Here it is concave up. What do we expect to happen to the function between 2 and 4?
Increase.
It has to flip its concavity. Let's see if it happens. Pick an easy number that is between 2 and 4.
3.
We are picking 3 and plugging it in the second derivative. So we have 12 times 3 minus 4 times 3 minus 2. 12 is a positive number. 3 minus 4 will give me a negative number. 3 minus 2 would give me a positive number. Positive times negative times positive is a negative number. Agreed? If the second derivative is negative for a test value between 2, what do we expect to happen?
Concave down.
It has to be concave down. But in this case, x is equal to 4 is both a point of inflection as well as a critical value, right? So what do we expect to happen? We want a change in concavity, so pick an easy number between 4 and infinity.
5.
5. 12. 5 minus 4 is 1 and 5 minus 2. 12 is a positive number. 5 minus 4 is a positive number. 5 minus 2 is a positive number, which gives me a positive number. Yes. So it has to be concave up. Yes? So remember that picture that I tried to draw so awkwardly earlier? Right? I kind of drew it over here. Do you see that shape? So my view, I mean, I could be wrong, but my view is the function should look like this. And that point would be 4. This would be 1, and 2 is over here. 1, 2, 4. Good. Who remembers? Well, let me ask. Who took algebra? Okay. Moses, you did too, but you're shying away. Yeah, took it with me, make me proud. So, what is the behavior of a function that has multiplicity? Don't remember? Okay. So that kind of looks like that picture, but it doesn't at the same time. So we have to zoom in a bit. Now that we know things are happening around 1, 2, and 4, we can narrow that window and focus between, say, -1 and 5, right? That's the reasonable thing to do. So I'm just going to adjust this window to confirm what I got from the test is right. Zoom that a bit too. Okay. So that's what I see as a function. The only mistake that seems to have happened is right here. So the function is concave up for that part instead of crossing the axis. That is why I asked the question, do we remember algebra? What is happening at 4? Can you tell me?
It's constant.
Huh?
It's constant.
It's constant. So if you remember algebra, going to get closer to 4 now. So let's just go from 2 to 4. Change the axis. Maybe -2. And you can see that is at 4, right? And it is constant at 4. So when I sketched this, the only issue was it was concave down at this part, but it should have gone that way. And when I asked you about algebra, the original function is x minus 4 cubed, right? This is what we call multiplicity of a factor. That factor has an odd multiplicity. If a function has an odd multiplicity, the function is going to cross the axis at that point. Here it becomes 0, so that is a 0 crossing. If that were to be a power of 4, it would touch and turn. So that's from algebra. So now we can see that the function is in fact concave down, but it just doesn't cross the axis. But we get a good idea about concavity.